Hi everyone, my name is Joke Emmanuel. In this video, I'll be showing you how to calculate some questions in analytical geometry. Of course, this is my third part of the series. I have the first two series on this chapter. Please do watch them. If you have any question, let me know in the comments, and don't forget to subscribe this channel. I want us to do this example, and please subscribe the channel so that you get more videos. And have a pen, have a calculator, have a notebook so that you get notes, and you have a better understanding of what a circle is all about, especially in the analytical geometry problems. I want us to read what we have right here. We are saying in the diagram below, a circle with the center M, which is 5 and 4, touches the y-axis at N and intersect the x-axis at A and B. PBL and SKL are tangents to the circle, where SKL is parallel to the x-axis, and P and S are points on the y-axis. LM is drawn. So I want us to solve this problem in the autonomous sense. If you have any question, like I said, please let me know in the comments below. Now, I want us to unpack some of the things that are said on that statement, and also to analyze what we have. First of all, we are told that M is the center of the circle. So I'm going to highlight that it's the center of the circle. What else am I told? I'm told that PBL and SKL are two tangents on the circle. So I'm going to highlight those two circles. So I have a tangent right there. I also have a tangent which is a PBL, like I was told, and SKL. These are two tangents. Remember that the tangents are always perpendicular to the radius, meaning that here I have to figure out what could be the radius in this circle. So now I'm going to mark what could be the radius in this circle. Remember that the radius is the line drawn from the center to the circumference. Or some other book might say the radius is the half of the diameter, but in this case we don't have a diameter, we do have got the radius. So I'm going to mark that. I'm going to draw the line from the center to the point in the circumference. So I'm going to choose between M and K. I'm going to choose between M and K. Some of you might choose M and N, which is still a welcome in this example. So now I want us to pay attention to the problem itself. Now we are saying that from N, where if you check at N, the value of X there is 0, it moves to 5 units. You guys can see that moves to the right by 5 units. So that means that is our radius. So I'm gonna say, well, that is my R, which is 5 radius. I mean 5 units, I meant to say. And then you also have a 5 for this length here, which is 5 units, the radius of the circle. So you could have chosen other points from the center. It will still be 5 units in that case. So now if they say give us the diameter of the circle, it means the diameter will be twice of the radius. So it's going to be 5 in that case. Remember, the diameter is the line passing through the circle. So I mean passing through the center of the circle. So that is going to be your diameter. So it's going to be 5 plus 5. Therefore, you're going to have a 10 for a diameter of that circle. But in this case, it is not asked. I'm just giving you some hints so that if it is asked, you know what to do. Now, let us read the question. They are saying to us, write down the length of the radius of the circle having a center M. They want us to write what? The radius of the circle. So I'm going to say, well, therefore, the radius of the circle is going to be 5 units. Like I have identified that from the circle itself. And now they are saying to us, write down the equation of the circle having a center M in the form of that. And that format is when the circle is moved from the origin. Now we've got the center. Remember, the center is M, and where A and B in fact are the points of the center. And if you look at it largely, you will see that the value of A is 5 and the value of B is 4. Remember that the value of A is the x coordinate of the circle center, and the value of B is the y value of the circle center, where r is the radius. Of course, we have identified that in part 1. So I'm gonna say therefore x minus a. What is a? A is 5. I have to square that, plus y minus b. What is b? B is going to be 4. Remember that the b is the y value of the circle center. Remember to square that. That is going to be equals to the radius, which is 5. I have to square the radius as well. So if I'm to simplify that, I'm gonna have x minus 5 all squared plus y minus 4 all squared. That is going to be equals to 25. So this is the equation of the circle having a center M. So this is how I will work it out. Now let's check the next question, number 3. They are saying to us determine or calculate the coordinates of A and B. We want to find the coordinates of B. But what we know about the point A and B is that they touch the x-axis, or they intersect the x-axis. So at the x-axis, what we know is that y is 0, and at the y-axis, it means x is 0. So in this case, at the point A and B, we have got the value of y. We know the value of y is 0 there. So I'm going to say to myself, therefore, at the points A and B, what I know there is that y equals to 0. They intersect the x-axis. So I'm going to highlight that so that you guys have a view of that. So we've got the y being 0 there. What I will then do is I'm going to substitute 0 in this equation wherever there is y, and then solve the value of x, because I don't know what are the x value. What I know there is that they are positive, but I don't know those values. But those values, you can see that the x value at B will be bigger than the x value at A, or you can say the x value at A will be less than the x value at B, because A, it is equidistant from the origin right then. Now I'm gonna say, well, let me do that quickly. So I'm gonna say, well, this is x minus 5 all squared plus y. Y is what? Y is 0. So I'm gonna put a 0 minus 4 all squared. That is going to be equals to 25. I have to expand that very simple in the usual way. Let's do that. Just a basic algebra. It's going to be x squared minus 10x plus 25, and then this one is going to give us negative 4. I have to square that. It's going to become a positive 16 minus 25 equals to 0. I'm going to say therefore, let me simplify it out first. I'm going to get x squared minus 10x, and then you can see that clearly that 25 takes away 25 right there. You'll be left with what, with positive 16, and then now we have no other choice than to factorize that equation. It's quadratic, very much easy. So I'm going to factorize down. So it's going to be x, and then you have what? You have 2 and what, and positive 8. And then they're all negative, since the middle term is negative right there. So what it means is, it means that the value of x is going to be equals to 2, or x is going to be equals to positive 8. These are the x values at what? At point A and B. Like I said, at the point B, the x value will be bigger than the x value at A. So this will then mean that you will say to yourself, therefore, the point A, it's when x is 2 and 0, and then the point B, it should be bigger than that x value, which in our case we called it as 8, and then I'm gonna say the y value at B is still 0. That's where the circle intersect the x-axis. So this is how I'll solve the points A and B in the third part of the equations. Now let's go to the fourth one. We are saying hence or otherwise determine the following. The first part is to find the gradient of what? Of MB. Now we know what is the point B, we know what is the point M. M is 5 and what? And 4. And then B, it's 8 and what? And 0. I'll then say to myself, well, it's very simple. So I'm gonna get the gradient of MB, which is going to be YB minus YM divided by XB minus XM, which is going to be, what is YB? YB is gonna be 0 minus YM. YM is 4 divided by XB. XB is 8 minus XM. XM is 5 right there. XM should be positive 5. Let's see that. So I'm gonna say, well, in the numerator I get negative 4 over 8 minus 5 is just 3 there. So I'm gonna get minus 4 over 3. This is the gradient of MB. We get 2 marks for that. Now let's see how we get the B part of the equation. Determine the equation of the tangent PB in the form of y equals to mx plus c. PB, I'm gonna go look at PB. What is PB? The one, that equation of the tangent. We know the gradient of what? Of MB. We know the gradient of MB. So the gradient of MB is going to be perpendicular to that tangent PB in that case. So what I will then do is I'm gonna say to myself, okay, this is very much easy. Look, I'm gonna have the gradient of MB multiplied by the gradient of a PB. They are gonna give me -1 because MB is the radius and then PB is the tangent. So therefore, when I multiply those two gradients, they are going to give me -1. So this will then mean that the gradient of PB, is going to be the negation of that number, which is going to be positive 3 over 4. This is how I'm going to get the gradient of a PB, the tangent one. So then this will then mean that you will have y equals to m, the gradient of the tangent, which is 3 over 4 x plus c. So because I need a point of contact to substitute that. So I'm gonna use the point B, plus I know the point B now, so I'm gonna utilize that point. So I'm gonna say to myself now, at a point B is 8 and 0. So I'm gonna substitute this point into that equation and be able to get the equation of the line. Let's do that quickly. So this will then mean that y is 0 at that point. You have 3 over 4 into x. What is x? X is 8 plus c. Let's see what is our c now. This implies that we have a value of c. Let's solve for c quickly. It's gonna be 3 times 8, it's going to be 24 over 4, it's going to be 6. So transpose that, it's going to be -6. So now the equation of the tangent that is required here is going to be y equals to the gradient, which is 3 over 4x plus c, where c is negative. It's -6 in that case. I'm going to write -6. Also, I'm going to highlight that answer for myself. I'm just going to highlight it. So this is going to be the equation of the tangent PB in the form of y equals to mx plus c. Now I want us to go to the to the fifth question. Now let's read that. They're saying to us, write down. When they say write down, it means there's no energy required right there. It might be tricky, but no, not that much. Write down the equation of the tangent SKL. Now they want us to find the equation of what? Of SKL. It is the equation of the tangent. But I want us to be careful here. Look, right from here to here, that is 5 units. That is 5 units. And then from here to here, right there, which is basically the length from here to here, and we are saying there is the y value, which is 4. So this is also 4. So the length of SKL, I'm going to get the y value at S, because it's going to be parallel. I mean, it's going to be parallel to the x-axis, which means that and I was told that SKL is parallel to the x-axis right there. So what I will then do is I will say to myself, because it is parallel to the x-axis, what it means is, it means that y remains constant. Y remains constant, because it is parallel to the x-axis. So it means that y remains constant in that part. So what I will then do is I'm gonna get the y value at S. So to get the y value at S, it means it moves from the origin, which is from n. When it gets to n, it's 4 now, and then from 4 there's a 5 units right there. So I'm gonna add those two. So I'm gonna say to myself, well, therefore y at S there is going to be 4 plus 5, which is going to give me positive 9 right there. So we're looking for the equation of the SL, which means this is the line y equals to 9. So I will say to myself, well, the equation is the horizontal one. So I will say to myself, very simple, the equation of the line SKL is going to be equals to 9. This is going to be equals to 9, because it's y, where y is constant, because it's parallel to the x-axis. When we say the line, this line here is parallel to the y-axis, we're basically saying that x remains constant. So here we're saying that SKL is parallel to the x-axis. What it means is, it means that the value of y remains constant. But if a vertical line now is parallel to the to the y-axis, what it means is, it means that x is going to remain constant for the duration of that line. Thank you very much. Now I'm gonna go to the sixth question. Now, hence or otherwise, determine the coordinates of L. Determine the coordinates of L. Determine the coordinates of L. I want to find the point L there. I'm just going to highlight that. I want to find the point L. So when you look at the point L, it's an intersection of 3 lines: the line SKL, and the tangent PBL, and the line ML, which is drawn. You were told that ML is drawn. So it's the intersection of 3 lines right there. So now when 2 lines intersect, you can equate their 2 graphs, and then I mean there are 2 equations, and be able to solve either x or y in there. But in this case, I'm going to solve for x, because at the point L, y value is 9 there. Remember that y value is 9, because SKL is parallel to the x-axis. So what I will then do is, I'm going to say to myself, I want to get the x value at that point L. How do I do? I'm going to equate the equation SKL and PBL, because that's where they intersect at L. So I have the equation of PBL, that tangent, I got it. I think it was in the B part of the 4th question, so which was that one. So I'm gonna say I have 2 equations, which is y equals to 3 over 4x minus 6, and I also have a line y equals to 9. I mean y equals to 9. The line of SKL and the line of PBL. So what I'll then do is, I'm gonna solve the value of x, because I see that these 2 guys, or what I can do is I can substitute the value of y there in that equation and solve the value of x, because y remains constant. So I'm now going to solve for x. Now let's do that. So I'm gonna have I'm gonna equate these two graphs, these two lines right there. So I'm gonna have a 3 over 4 x minus 6 is equals to positive 9. So then now I'm gonna have 3 over 4 x equals to, I transpose that, it's going to be 15. So let's solve for x a bit. This implies that x is what? Let's solve for x quickly. We are going to get x as 20. So this will then mean that the point L is when x is 20 and when y is 9. So the point L is it's 20 and y value is 9, right? Then this is how, guys, I'll solve those 2 x values, those points, x and the y. So I'm going to repeat this one. Look at the point L. This is where SKL and the line PBL meet. So I'm going to equate their 2 equations to get the x value on the y value, but the y value remains constant at that point, which is 9. So you could then substitute 9 into that line, or you can equate the 2 equations, which will still get the same x value as 20 in that case. Now I'm gonna go to number 7. They're saying that determine the length of ml. The length of ml, you now have the point L, you also have the point M, which was given at the center back then. So I will say to myself, therefore the length of ml will be found by the square root of xm minus xl. I have to square that, plus ym minus yl. I'm just putting the formula down. And then now what is the x at m? X at m was 5. What is the x at L? This was 20. And then I have to square that, plus the y at m, it was 4, minus the y at L, which was 9. And I remember I have to square that, and then I have to simplify it carefully. Let's do that. So this is going to be minus 15, I guess, all squared, plus 4 minus that is minus 5 all squared, which will then give us the value of what of 250. And then now you can simplify that in the third form. This is going to be 5 into the square root of what of 10. It's basically like 25 times 10. It's going to give you 5 square root of 10. Just there is no work there, just the length of ml. That's very much easy. Normally you use a distance formula for that. And then now number 10, we're saying determine the equation of the circle passing through the points K, L, and M in the form of that one. Okay, determine the equation of the circle passing through the points K, L, and M in the form of that one. So remember that when you have to find the equation of the circle, you need to get the center, you need to get the radius. Those are the 2 things that you need. The center, which in this case is the point A and B, and you also need the value of the radius, which is R. I'm gonna go look at at where the circle passes through. The circle passes through the point what? K, L, and M. I'm gonna go look at the diagram carefully again. So what I will then do is, now I'm gonna erase everything, or even if I don't have to erase it, they are saying it's K, L, M. It's K, L, M. Look, the way the circle passes through KLM, we're talking about this triangle. We're talking about this triangle right here. So that triangle is a what? It's a 90. It's a right angle triangle, because this line radius is perpendicular to that tangent. So this is a right angled triangle, and we are saying that the circle passes through these points. This means that this is the, sorry about that, let's do that quickly. Just gonna remove that, thank you. Now I want to get the center of this new circle that passes through the point. So I'm gonna say, well, this circle passes through that. This is a new circle. It passes through a right angle triangle. So you and me know that if it's a right angle triangle, this means that it's going to be your diameter, because this one is 90 degrees from Euclidean geometry. So this is going to be the diameter of the new circle. So now this means that you're going to have a center somewhere there. You're going to have a center somewhere there, which we have to work it out, that center. Now, how do we work that center out? Remember that if this is a diameter between those 2 points, M and L, it means that you're going to get the center now. You're going to get the center. Say maybe the center now is what, I'm just going to get the new center. I'm just going to say maybe it's W. I want to get that point, W. How do I find that? I use the midpoint formula. So I'm going to say, well, let me get the center first, which is going to be the midpoint of ML. So I'm going to say, well, the midpoint of ML, just going to write that, the midpoint of ML. So it's going to give us the coordinates of W, which is going to be x1 plus x2 divided by 2, and then you also have y1 plus y2 divided by 2 is the midpoint formula. So W, you're going to have x at L, which is 20, plus the x at M, which was 5, divided by 2, right there. And then now the y at L, the y at L was 9, plus the y at M, the y at M was 4, divided by 2. So this will then give us the new center, which is going to be 25 over 2. And then let's do that. We're going to get what? We're going to get 13 over 2. This one is the new center of this new circle we are dealing with now. It's the new center. And then how do you find the radius that passes through that point? Remember that the radius is the half of the diameter. So I'm going to say, well, the radius, just going to write it in the different color. So the radius is going to be equals to half of the diameter. So the diameter is ML. So this means that this is basically like a half of what? Of ML. And I think we were asked to find the length of ML in number 7. And we found that to be 5 square root of 10. So it's basically like a half of that. So it's going to be 1 over 2 multiplied by a half of ML. ML was what? ML, we found it to be 5 the square root of 10. So this means that the radius of this new circle is 5 the square root of 10 divided by 2. So you've got the center, you've got the radius. Now what you need to do is to write the formula in that format. So you will then say to yourself, therefore x minus a all squared plus y minus b all squared, this must be equals to r squared. What is your a? Your a is the x coordinate of this new center, which is 25. So I'm gonna say, well, this is x minus a 25 over 2. I have to square that, plus y minus the value of b. The value of b is the y value of the circular center, so that is going to be 13 over 2, and then I have to square that. That gives me the radius. Let us square the radius. It's going to be 5 the square root of 10 divided by 2, and then I have to square that one. So therefore this will be x minus 25 over 2 all squared plus a y minus 13 over 2 all squared. Now I have to use the calculator for that. Let's see what we get. We get 125 over 2. So this is how I'm going to work